Hello guys, welcome back. In this video we're going to do the third kinematic equation. Okay, so the third kinematic equation. Right. Now the first two equations, as we found in the previous videos, where the first equation was v is equal to u plus at, and the second equation was s is equal to ut plus half at squared. V, that is final velocity, is equal to u, that is initial velocity, plus acceleration times time. Now the second equation is displacement, that is s, is equal to initial velocity multiplied by time plus half into acceleration times time squared, right? So these are two equations. Now if you observe these two equations, you will know that in the first equation you are relating velocity with acceleration. In the second equation you are relating displacement to acceleration. In the first video you are relating final velocity with acceleration, and the second equation you are relating displacement with acceleration. But you do not have an equation where you directly relate velocity with displacement. You have to find an equation where there is a direct relation with between velocity and displacement. Direct relation between velocity and displacement, which you do not have in these two equations. Right? So what I basically have to do is I have to convert this first equation into an equation where I have at least one displacement term in this equation, right? So I have to convert any of these two terms, any of these three terms, u, a, and t, to a term which has s, so we can relate v with s. Okay. Now in the previous video I also discussed that v average is final velocity plus initial velocity over 2, right? That's how v average. V plus u over t, final velocity plus initial velocity over 2. Sorry, v plus u over 2. Okay. So that's how v average. Now, what is displacement? Displacement is v average multiplied by time, right? Now, as you can see, we have a time term and a velocity term and a displacement term in this equation, right? So what we are doing is we are having, well, what we have over here is we are having a displacement term in terms of time, right? So if we plug this, if we rearrange this equation and get this equation where t is equal to something of s, and then put that value of t into over here in this equation, we're gonna get an equation where v is related with displacement, right? So because this quantity is gonna be displacement, something of displacement. So we want this equation, we want to convert this equation where t is equal to something of s. So let's just rearrange this equation. First, what is v average? V average is v plus u over 2, right? So v plus u over 2, then multiplied by time. Now we want to convert this equation. I mean, we have to have t on one side of the equation, right? So let's just take this 2 over here on the other side. So 2s is equal to v plus u multiplied by time, right? So if we take this on the other side, we're gonna have t is equal to 2s over v plus u. Now let's just plug this value of t in this equation. Let me just use a different color for the convenience. V is equal to u plus at, right? So if we put in the value of t over here instead, we are gonna have v is equal to u plus a times 2s over v plus u, right? Now we don't have this kind of looks ugly, right? So we don't want to have anything in the denominator. So let's just multiply this whole thing by v plus u, so that this v plus u is gonna get cancelled, right? So v into v plus u is gonna be u into v plus u plus 2as, right? If we just multiply these things, we're gonna get v squared is equal, I'm sorry, not v squared plus uv is gonna be uv plus u squared plus 2as, right? Now these two uv terms get cancelled, so we are left with v squared is equal to u squared plus 2as. So we finally have an equation where there is a direct relation between velocity and displacement, and that's our third kinematic equation. V squared is equal to u squared plus 2as. That's our third kinematic equation. Okay. So if you guys have any questions at all, just make sure to just put the questions in the comment box, and I'll reply to you as soon as possible. Okay. And in the next video we'll probably do some problems, right? And then we'll move on to some other advanced concepts, and then Newton's laws of motion. Okay. So I'll see you guys in the next video. Thank you very much.